Hi, Chris McLoone here for this episode of TIC Talk. Today, my guest is Manfred Kihn, and that should be a name that most everybody knows at this point as far as from what we do. Manfred creates the column every month that we have in Fire Apparatus and Emergency Equipment on thermal imaging. He's done a couple of webcasts for us, so no stranger to us. But Manfred, for anybody who might not know you, would you just give a quick intro?
Sure. Thank you, sir. It's a pleasure to be here. My name's Manfred Kihn. I'm retired from the fire services from Ontario, Canada. I've been with Bullard going on 20 years as their thermal imaging trainer. I've had the glorious task of traveling around the world to Asia, Middle East, Latin America, United States, Canada, Asia's. I mean, it's just been a glorious ride to be able to preach a gospel of thermal imaging to various fire services, and obviously write for your column as well too. So yeah, it's a pleasure to be here today.
Well, perfect. Now today we're going to talk about temperature measurement with thermal imagers, and as far as thermal imagers have come and as easy as they have become to use, there are still tricks to interpreting what you are seeing on the screen, and temperature measurement is actually one of those things where we may not actually be seeing what we think we're seeing, and then we'll get into that. So there are misconceptions sometimes about what that temperature measurement is telling us. So to start us off, could you talk about some of the most common misconceptions firefighters have about temperature readouts and their thermal imagers?
Sure. The very first thing I want to acknowledge a fact is that no thermal imager on the market is a thermometer. Thermal imagers basically process infrared, detect, which is basically heat. With that process, we have a reference bar on the side for temperature measurement, and depending on the make and model of your imager, you're going to have a digital number in the lower right-hand corner. What NFPA did back in the 1801 2025 standard was basically removed that digital number because firefighters were using the imager as a thermometer. And unfortunately, they were getting incorrect readings, subsequently getting hurt, getting killed, and not reading what the imager is interpreting to them in terms of what the information is on the display screen. So in the 1801 standard, NFPA and any NFPA approved certified imager remove that digital temperature. It can come back in when they change the imager from a basic to a basic plus mode. All other imagers, unfortunately, do have that digital temperature in there. So again, it's something to understand that learn what your imager is capable of doing. Again, some departments will get one of those heat guns, those laser heat guns, and they'll do a side-by-side comparison to see exactly how accurate their imager is or isn't. The biggest thing that I have found in my experiences, and again, when manufacturers are calibrating the imagers at the very beginning before they're completed their manufacturing process, they could be out plus or minus 5 degrees, as far as plus or minus 41 degrees. Take that into the field as a firefighter now, not understanding what it is. And again, the temperature measurement is based on the little square box in the center of the display screen. Now, again, the newer imagers have that. Older imagers have a little green cross in the center. That's the focal point for your temperature measurement. And again, where the firefighter is pointing at it, the imager detects a relative surface temperature. So you can't walk into this room and go, oh, it's 800 degrees in here. It's where the imager is pointed at in terms of that little green box. Could be the wall, could be the ceiling, could be the chair, could be the table. That's the temperature that the imager is going to be detecting. And again, angles of view. There's so many different variables for that temperature. So the misconception is, hey, you know what? The door is 140 degrees. No, look at the door because I'm seeing yellow. And again, some imagers produce colorization at 300 degrees, some at 500 degrees. If you're seeing yellow and the temperature is telling you 140 degrees, there's something wrong.
Could you talk real quick about that basic and basic plus? I think that's an important thing to explain regarding the settings on your thermal imager.
Right. So what NFPA did, they standardized with all the manufacturers. So the only thing that you can have is black and white grayscale, a temperature reference bar on the slide, on the basically a sliding rule on the right-hand side of the display. You got your battery indicator measuring the power that you have left in your battery. In the center of the display screen will be that little green temperature reference bar. And then in the upper left-hand corner, you're going to have a high gain, low gain indicator, which is a green box and a green triangle indicating that the imager has shifted or shuttered from high gain to low gain. And again, your black and white grayscale, and then your yellow, oranges, and reds. And that's standard amongst all manufacturers. So that, the NFPA wanted everything to be the same. We as manufacturers, we can add different color palettes, different options into the imager, zooms, thermal throttles, so many different things. But NFPA wanted to standardize so that when you pick up that imager in the basic plus mode or the basic mode, this is what you're going to get is black and white, grayscale, yellow, orange, and red, period. Once the operator or the end user switches the imager from basic plus mode, now all the other features can come in for user selectable color modes. If you're doing, if you're doing your overhauls, things like that. If you're going to be using your zoom, 2x, 4x zoom for rescue, things like that. One of the things that is not under the NFPA is digital video record. That can be on at any time in basic or basic plus mode, regardless, because that has no effect with the NFPA. So those are basically the two differences. And that is when you flip the imager over, you're going to have an NFPA certification sticker on there to indicate that the imager is certified by NFPA. And it's I don't have one of those here with me. It's just basically to certify that imager is gone through that process.
And again, that's NFPA compliant camera or imagers will have the basic and basic plus, correct?
Yes, that's correct. Yes.
Okay. Now, when we talk about accuracy and some of the limitations that there may be, because these are still tools. They're not a perfect tool by any stretch of the imagination. And of course, the user is sometimes the weak link there if they're not interpreting what they're seeing on the screen properly. But I guess in general terms, how accurate are the temperature readings that we see on a thermal imager, especially when we get into, a fire environment, whether it's a room and contents, whether it's kind of a fully involved structure? What's the accuracy of those measurements?
I mean, there are so many factors when it comes to that temperature measurement, and I mean the what's burning inside the structure, the density of the smoke. Again, you could have mattresses that are burning, and again, you've got a lot of rubbers and everything that are inside there, and that could change the density of the smoke versus, I've got a lot of wood inside, so the density might not be the same. So that's going to have a lot of effect. The temperature, distance. There's so many different factors that you can put into it. Again, what's burning, distance. Again, the type of material that's within the structure, ceiling temperatures, firefighter comes in. I mean, one of the things that NFPA has done over the years is put so much thermal protection into gear. So firefighter goes in, it's not that hot in here, but yeah, he looks over his head and it says 800 degrees. What's the 800 degrees being measured at? Is it the ceiling? You see all this kind of thermal layering. And again, one of the questions I always ask firefighters when I'm doing the class is, do you know what your helmet's rated for to pass temperature for NFPA? And it's sad when a lot of firefighters can't, 1,200 degrees, 1,500 degrees. Wrong answer. It's 500 degrees for 5 minutes. And that's all helmets. So here I am, not really feeling the heat, but yet I don't understand what I'm looking at. If I'm seeing all this nice thermal layering, this nice little flow path coming down the hallway, I think perhaps I want to be down on my hands and knees, crawling around, because if it says 800 degrees, well, wait a second, where is my imager taking that temperature from? Is it going right through the convected heat currents and it's hitting the back wall? Is it hitting the ceiling, or is there something in behind that maybe the imager is not detecting? And it could be a false positive. So I would not personally rely on any temperature. There is a point in time when I am going to use the temperature, like such as things like overhauls and things like that, where I want to see if something is increasing or decreasing in temperature after the fire has been extinguished. But in the first part, I would rely on what we call image interpretation. And that is, over time, the more you use the imager, the more confident you're going to become in your ability of understanding what you're going to see in that 3.5-inch display screen. Understand black and white grayscale. Everything that is white is hot, black is cold, everything in between are shades of gray. And pretty much 95% of the time, that's what you're working in is a black and white grayscale. Because when you see, I call it putting the wet stuff on the red stuff, as I'm going down that hallway and it's black and white and suddenly I see colorization, I'm already hitting that with the line. I'm knocking that down. That kills the color. I'm back into black and white again. So again, it's the importance of that image interpretation. What am I looking at? And that's why I encourage firefighters as often as they can, take the tool. The thermal imager is a tool. Take it off the apparatus when you're at the firehouse. Wander around and look at everything you can possibly look at. Take it into your kitchen. Turn on your stove if you got a nice propane or gas stove. Turn that on. Look at your elements. Oh, I've got some stainless steel in behind. All of a sudden, I turn on one element, but I see 4 fires. Why do I have 4 fires? Where 3 are actually reflections. And again, that can happen in a structure fire when you're picking up, from the big screen TV set or the stainless steel appliances. I'm picking up reflections, multiple images. But yet my imager is telling me this is what the temperature is, but it's actually a reflection. All right. So again, it's giving you a false image.
So you touched on real quick there some of those, a number of factors that can throw off a thermal imager's temperature measurement. Could you go into the how that happens? Like you just mentioned, the reflecting. Just talk about some of those factors, but how they throw it off so that, again, we can interpret what we're looking at properly.
Okay. So any shiny, glossy surface, gloss paints, gloss wallpapers, glossy concrete floors, linoleum floors, hardwood floors, glass mirrors, again, stainless steel appliances, anything like that causes a reflectance. So I'm just going to give you a little example here. This is what we call a Leslie cube. And the other day I did an experiment with it. It's just a tin box, but it has different sides in terms of contrast. I filled this up with boiling hot water and I put a thermal pen into it. I use actually for barbecuing, and it registered 193 degrees. Pretty accurate temperature. I trust it for when I'm doing my brisket, things like that. I'm going to trust that temperature. But yet I went around to the different sides of the boxes and I picked up a temperature. It was originally 193 degrees. I got 107 degrees, 151, 154, and 166 degrees, all from these different sides. So, and I tried to pinpoint in the center on every side. Now, again, a firefighter who is not, I'm going to say, well trained in thermal imaging. All right, the imagers arrive, you play around with them, you never receive a proper training course, so you just do a little bit of dabbling with the imagers, and he's not that well experienced in using a thermal imager, and he may not realize that focal point of the temperature has got to be, again, the angle of view, the direction, how you're looking at things. Again, will have an adverse effect on that temperature. So again, these are the big things that I find that firefighters need, practice. And it starts back in the firehouse. And again, it's what you're looking at. Understanding the reflectance is a huge thing. So we'll do a little example here. Everything everything on Earth has an emissivity value that the imager will detect except absolute zero, which isn't a minus 275 degrees Fahrenheit kind of thing. Now, what happens at this point in time? I've got 2 pieces of wood, piece of pine and a piece of oak. I light both on fire at the same time. What's going to burn the fastest? Obviously will be the pine. What's going to burn the hottest will be the oak. If I extinguish both at the same time, what's going to stay warmer the longest will be the oak because it's a more denser material. But yet there's still 2 pieces of wood. But if I'm looking at them with an imager, I can read 2 different temperatures, right? Concrete block doesn't burn, but it takes a long time for it to heat up. It takes a long time for it to cool down. Again, it has a different emissivity. So having said that, that's what the imager, as a manufacturer, we go through and we calculate all these different emissivity values. And emissivity starts basically at 0.0 going up to number 1. So again, let's take your firehouse, for instance, and I encourage firefighters to do this often. They come in on shift. They've, checked over their vehicle and their equipment. They've had some breakfast. Take the thermal imager, go outside before the sun comes up. It could be 8, 9 o'clock in the morning. Do a 360 around your firehouse. What's the roof made out of your firehouse? You could have brick, or I mean, you could have asphalt shingles. You could have a steel roof. You could have cedar shakes. You could have clay tiles, depending on where you live. And then again, the construction of the building itself. What's it made out of? Brick, stucco. What are your apparatus bay doors made out of? Things like that. Measure the temperatures on all four sides of the structure, from the roof level all the way down, doors and windows. Pretty sure you don't have a basement in the firehouse, but again, down to the ground level. Do that in the morning, do that again right after lunch, and do that again in the evening. And you're going to get 3 different emissivity values, or 3 different temperatures based on things that we pick up: solar loading, by the sun, earth rotation. But again, it's the material that you're looking at will retain heat longer. Again, mid-afternoon sun beating on that nice brick wall or that stone wall, 10 o'clock in the evening when you go out again, you're wondering, why is that wall still hot? Why am I still receiving a high temperature? Again, remembering that emissivity. But yet I'm going into the structure fire. I've got reflectance. I'm going to have a very different temperature because it's going to reflect off of there, and I'm going to have bouncing around temperatures to go, why? Look at what the imager screen is giving you for interpretation. Zero at that little digital number. Don't even look at it. Put your thumb over it. Put a piece of tape over it. Don't even look at that digital number, because it's just going to bounce around. Anything that's within that structure, any kind of reflectance or anything, is really going to mess things up. I know I rambled on. Sorry.
No, you're good. Well, because I mean, like basically, I mean, you've just been training the audience on some of the finer points. But when it comes to relying on color palette or instinct, are there specific things you do when you're training firefighters to interpret temperature data versus relying on instincts, palettes or instinct? I mean, you get around, you must have seen quite a few examples. Are there any kind of, I don't know if I'd call them generalities, but best practices almost, or in terms of interpreting that temperature data versus, relying on instinct or the color palette?
Yeah, and a lot of that is to do with the make, model, age of your thermal imager. Okay, refresh rates. Imagers have really improved over the years in terms of the shutter speed or the refresh rate, in terms of when you're scanning with the imager and the shutter basically fires off. What it's doing is processing the infrared, and it's refreshing itself to give the end user the clearest imagery at all times. Now, again, refresh rates, you can have a situational awareness imager, which are the little guys, little Scott sites, little Seeks, the MSA MyTics, things like that, where you're going to have anywhere from a 9 to 15 hertz refresh rate, which is very, very slow. Where we get into the advanced decision making, starting at 25 hertz up to 60 hertz, very, very fast refresh rate. Now, again, I've seen firefighters, again, grab the imagers and they're just zipping around like this. Well, the problem is your brain cannot compute. Here I am, 180 degrees, naked eye. I can see this in depth, definition, colorization. But now I no longer have that 180 degrees. I'm now looking through this black and white, this display screen, and I'm looking on black and white grayscale. All right, your imager will produce color, depending on the manufacturer, 300 or 500 degrees. But right now, we're not at color yet. We're still in that black and white phase, getting in to understand that, okay, we're starting to pick up a little bit of heat. We're starting to pick up some convective heat currents. We're starting to see that flow path. We're starting to develop that neutral plane. This is all going to be on black and white grayscale. All right. At some point in time, all of a sudden, your imager is going to boom and kicks into color. And it's like you could go from yellow to red in a heartbeat, not understanding what it is that you're looking at. And at some point in time, should I have I been flowing water already? It's one of these things where some guys are afraid to open up the nozzle too soon, because it's a lack of experience on the end of the imager and understand what it is that you're looking at and the various limitations. So again, the importance of training and practice and getting out there as much as you can. But the colorization shows you the progression of the fire. Knowing the fact is that, I'm gonna say like Bullard, we're at 500 to 800 degrees is yellow, 800 to 1,000 is orange, 1,000 degrees plus is red. Knowing that my helmet is 500 degrees rated for, and I'm in the black and white grayscale, again, in the upper left-hand corner, my imager at some point in time, as I start to get into elevated temperature, my imager is going to shutter and it's going to go from high gain to low gain. That's my early warning indicator right there that I'm starting to progress into elevated temperatures. When should I be flowing water? Again, the conditions dictate on that display screen based on experience to go, yeah, I should have opened that nozzle 20 feet back as we made entrance into the room and hit the ceiling a couple of times just to kind of, kill the heat, knock it, kill it. These are things that with experience and training that you look for and that you look at. An inexperienced firefighter, like you said, he may get in there, oh, it's not that hot, it's not that hot. He's looking over his head, not understanding what he's looking at. Suddenly comes around the corner and he's hit with that. Suddenly that imager screen lights up in the yellow to red. And at that point in time, he's got a split decision to make. I got to open that nozzle. It might, at that point in time, may be too late. So these are all things to look at and to take into consideration, training.
When we talk about, I guess, success stories and stories where maybe the outcome wasn't quite what we wanted, and given your experience in the fire service as well as all the training that you do you have any examples of where misunderstanding a temperature reading on a thermal imager led to a mistake or a less successful outcome? Or at the same time, do you have any examples of where reading it correctly really had a major impact on the outcome and made a big difference at the call?
Well, one of the critical decisions that NFPA made in terms of removing that digital number out of in the 1801 standard was firefighter misread the temperature on a door and said it was 140 degrees. It was a fatal outcome, unfortunately. Maybe he should have looked at what was around the outsides of the door. You're seeing colorization. Again, those are my trainings when I throw up several pictures and several videos. So you guys want to open this door? Don't look at the digital number. I'll go up to the screen and I'll put my hand over it. Don't look at this digital number. Read image interpretation. What's this image telling you? Would you want to open this door? And they're like, again, these are the success stories in educating firefighters. I'm going to show you the doors that you do not want to open. You will understand which doors you do want to open when the time comes. But these are the doors I want to show you because not every day do you get that opportunity and training to understand that these are fatal decisions that could be made if I wasn't paying attention in class, if I wasn't listening to the instructor. I'm just kind of sitting there on my phone, playing, texting somebody, not paying attention. And then, what was that you said again, sir? Oh, I'm sorry, I missed that. Well, you know what? Do you want to open this door? Oh, yeah, it's not that hot. Well, hang on a second. Read the image interpretation. I live up here in Canada. So what happens on our doors up here? We have this little thing called weather stripping. Keeps the cool draft coming in from the wintertime. Well, that's going to melt out first. So what am I going to see around the edges of my doors? Bright white, perhaps yellow. Be a good indication because I've got a very solid double core door. And again, if I take the temperature measurement at the door, it's going to give me one thing. But if I look at my image interpretation, it's going to tell me something different. As a firefighter, that's the information that I would want to know. That's the information I would rely on, based on experience.
One of the common threads, maybe the most common thread throughout all of the episodes we've done so far, and among all of your articles just about is, and you've just used the term a number of times here, image interpretation. It's not just it's not just flashing the thermal imager up and seeing what's in front of you. You have to interpret what's on the screen in order to glean the correct information there. And you've talked about some of the informal training that can be done. A guy's just going into the firehouse, taking it out, doing that 360 in the morning, doing it again in the afternoon after the sun's been shining for a bit. But are there things that fire departments can do to build better training programs, the more formal training programs around temperature measurement? Because you want to avoid becoming overconfident with the use, but you also don't want to underuse the temperature measurement features of a thermal imager. So are there things departments can do to build better training programs specifically around that, whether it's a program designed specifically or tailored specifically to temperature measurement or a component of the overall training program? You've mentioned a lot of times in your columns about how it drives you crazy when a fire department doesn't have a thermal imager component in their rookie fire schools, and then they come out and now they're it's carried on the truck. That's the tool that you're supposed to bring with you, and they don't always have a real good feel for what they're looking at on that screen. So I apologize, I droned on there for a second, but are there things that departments can do to build better training programs around temperature measurements so that you're not getting overconfident, but then at the same time you're not underusing that feature of the camera?
Yeah, I mean, yeah, and that's a good question. I mean, like anything in the fire service, we train on every piece of equipment that we have. I mean, from a Halligan bar and axe, ladders, ropes and knots, nozzles. I mean, SCBA, our extrication equipment. We train on everything that is there. What I find a lacking of is training in thermal imaging, and it's not because of ignorance, lack of knowledge. Programs are available out there. There's all kinds of information available on the internet, magazine articles. There's several of us out there in the industry that write articles, and there's all kinds of videos that are available. So there's no lack of information. It's just a matter of someone, in a training division needs to have the interest and the desire to want to develop that thermal imaging program. And the other thing that I find a lacking of, and I believe this might be an article that might be coming out soon, is on standard operating guidelines. Departments haven't got them. And it's sad. Every department that I go into is, hey, show me a copy of your SOGs. And they'll look at each other. Yeah, we don't have one. Well, yeah, we have an SOG for everything we do in the fire service. It's the Bible. It's the Bible that we follow as firefighters, basically for due diligence, right? But we don't have one for thermal imaging. So again, the white shirts need to take the understanding from the top level all the way down to the training officers, right down to the recruit firefighters that are coming in, that this is an extremely valuable tool, and this is how you should use it, and this is who should use it, and this is when you should use it, and this is how you should maintain it. But, the onus is still back onto the individual firefighter, that here's this piece of equipment that is on my apparatus. I want to know every piece of equipment that is on my apparatus and how it works, because I could be tasked with having to use it. And I was a big pride when I was a firefighter. I went around my truck. I get in there in the morning and I open up every compartment. I checked every piece of equipment. I want to make sure it was going to run, because when we got that call, I wanted to make sure that, number one, I was able to perform properly, but I was proficient in the use of every piece of equipment under. Lives depend on it, right? Same thing with that thermal imager. All of a sudden now I'm a recruit. I've gone through my basic training. I've just graduated. I've become a firefighter, and I'm on engine 21. And here's this thing sitting in the charger, and I look, what is this? Well, it's a thermal imager. Well, we didn't learn anything about that, recruit. It should start right from there. So the guys should understand the basics. Perhaps when they get out into the field, it's going to be a different make and model. But you understand the thermal imaging is thermal imaging, regardless whose imager you're using. The concept is the same. It's a process of infrared. We're detecting heat. We're coming up with these neat heat signatures. And again, the training part of it is that, and I say this many times into my classes, I'd love to be this great guy that's going to hand you guys this silver platter with every anomaly or heat signature that I've seen in 20 years. Unfortunately, I can't do it, because we all see things differently, right? And I'll put up a couple of videos, and the guys will say, okay, what are you looking at? And they're all sitting there looking at it, and they haven't got a clue. Number one, do you detect a heat signature or an anomaly? And there's pause, and it's like, yeah, well, take a look at this. Here's my handprint. Stand up. There's your butt print. These are some of the basic things that we can do. And again, I'm going to say it again. Go around your fire hall. You're watching the basketball game or something. Guys have been sitting there. Hey, get up, take a look at their, what's in the sofa chairs or the lazy boy chairs. Go into the kitchen. Say guys are sitting down. These are the basics. You're learning how to crawl before you learn how to walk, before you how to run. And I still think it's the onus on the individual firefighters. It takes initiative to take that thing off the apparatus and be the best that he can be in order to go out there and save those lives that he's tasked to perform,
Well, again, Manfred, my thanks to you for sitting down with me today to talk about this stuff. Before I let you go, though, are there any general comments about temperature measurement and thermal imagers you'd like to make? Any top takeaways you'd like the audience to walk away with today?
Practice, practice, practice. Don't rely on that digital number. Understand image interpretation, because we all see things differently. And you know what? Take the time, go around your firehouse, set up some props. A hot cup of coffee, a cold bottle of water, something else, just some little props for the guys to go around and take a look at and say, okay, I've got an idea what this is, general ideas what this is. Run your compressor for your air compressor, for your SCBA. Take a look at that. Look at the temperature measurement. These are just things to get a practice and practice. And that's the onus. That's the onus is practice.
All right, perfect. Well, again, this has been Chris McLoone along with Manfred Kihn today. If you would like to see all of our TIC Talk podcasts that we have so far, they are all archived at www.fireapparatus.com/podcast. If you have a topic you'd like us to hit on in one of our episodes here of TIC Talk, please let me know. I'm at chris.mcloone@clarionevents.com. And of course, if you have any general topics you'd like us to hit on any of our podcasts, please let me know. Again, it's chris.mcloone@clarionevents.com. So again, for Manfred Kihn, this is Chris McLoone. Have a good one and stay safe. Thanks again, Manfred.
Thank you, everybody. Thanks, Chris.